The objective of this video is to use the unit circle, which means a circle with radius 1, to find trig values, very common trig values, and to apply that to problems and also to help us memorize some values. Now, first of all, let's define the unit circle. The unit circle is a circle with radius 1. So when we do that, if you want to make your radius 1, so if we have this be a unit circle, so we'll put our radius equal to 1 for this. We want to look at certain angle measures. Well, we want to apply this back to what you learned in geometry. You had some very special triangles that you worked with, a 45, 45, 90 and a 30, 60, 90. Let's start with the 45, 45, 90 degree triangle. Just remember that if we want 45 degrees to be in radian values, we would multiply this by pi over 180 in order to convert it. And so this would equal pi over 4 radians. All right, so now if we look at this triangle, remember the ratios you had for a 45, 45, 90 degree triangle was you had the legs each of would equal 1, then the hypotenuse would equal square root of 2. Well, what if I want to apply this to a unit circle where I want the hypotenuse to be 1 because then it would make it a unit circle? Well, if I want this to become 1, I have to divide each of the sides by square root of 2. This would make this side equal to 1. I'd multiply or divide this by the square root of 2 and this by the square root of 2. If I did that to rationalize this, I'd multiply it by the square root of 2 over the square root of 2, which gives me the square root of 2 over 2, because the square root of 4 would give me a 2. This would be the exact same side, square root of 2 over 2. Now, if you look at these values, if I take the trig values of these, if I wanted to do sine of 45 degrees, notice sine of 45 degrees, I would go with the opposite side, which is square root of 2 over 2, over the 1. That would just give me square root of 2 over 2. Now notice if I did cosine of 45 degrees, that's the adjacent side, which is square root of 2 over 2 over 1. It's the exact same value. So sine of 45 degrees equals square root of 2 over 2, and cosine of 45 degrees also equals square root of 2 over 2. Now, just so we apply it to radians, we could instead put in pi over 4. This would be the exact same statement if we were using radian values. So we have sine and cosine of pi over 4 equal to that square root of 2 over 2. Now, let's apply that to the unit circle. If we mark off a pi over 4 angle, so that would be a 45 degree angle, pi over 4, the x and the y would give me square root of 2 over 2, square root of 2 over 2, because those would be the values that would be on this circle. Let's apply that to coming up with the actual sine, cosine, and tangent every time on a unit circle. If you recall, sine on any circle would be y over r. Well, if r is equal to 1, sine of theta is just going to equal y, because the r is always equal to 1. Cosine, on the other hand, on any circle is x over r. If r equals 1, then cosine would equal x. And then for tangent, since it doesn't involve the radius, it's just y over x, we get the tangent equal to y over x. So on the unit circle, we can get these values, and they give us sine and cosines, because if you notice, the x value is the cosine value, and the sine value is the y value. So that gives us a nice, clean way of looking at ordered pairs on this unit circle and getting the cosine as the x, the sine as the y. Now, it also, you can notice that it applies to the other quadrants. So if I go with the 45 degree angle or the pi over 4 angle with the x-axis as a reference angle, in each of those, all I have to do is change the value of the x's and y's to reflect if they're positive or negative in the different quadrants. So I get the same ordered pairs, just you have to reflect the negative sign for the x and y. X is negative in quadrants 2 and 3. Y's are negative in quadrants 3 and 4. All right, so that's what happens with a 45, 45, 90 degree triangle. Let's now look at a 30, 60, 90 degree triangle. 30, 60, 90, our ratios are opposite the 30 is a 1, the hypotenuse is double that, it's a 2, and the opposite the 60 is the square root of 3. Well, if we want this to be a unit circle that we're dealing with, so the radius would equal 1, then we want this side to be the length here that going out to the circle, we want that to equal 1. So we're going to make the hypotenuse equal to 1. So 2 over 2 would equal 1. So I can divide everything by 2. So notice now I've got new ratios here I can use. I'm going to do sine of 30 degrees. And that's going to be the opposite, which is 1/2 over 1. Well, that's just going to equal 1/2. Now, if I do cosine of 30 degrees, notice cosine of 30 degrees will be the adjacent side, square root of 3 over 2, over the 1. That just gives me square root of 3 over 2. Now, let's look at the 60 degree angle and what the sines and cosines are in this triangle. Well, if you look at 60 degrees here, you go opposite it, and you're going to go with square root of 3 over 2 over the 1. That's the same as cosine of 30. That makes sense because 30 and 60 are complementary, so the cosine of 30 is going to be the same as sine of 60 degrees. If we look at 60 degrees and do the cosine of it, cosine is the adjacent 1/2 over the 1. 1/2 over 1, cosine of that would just be 1/2, which is the same as sine of 30. And since 60 and 30 are complementary, those two values are equal. Now let's apply that to radians. Just a reminder that 30 degrees in radians, if you multiply it by pi over 180, 30 degrees will becomes pi over 6. And then if we do 60 degrees in radians, we're going to multiply that by pi over 180. And if you do that and reduce it, you get pi over 3. So these are the angles there. So if I replace these angles with the radian values, I get instead sine of pi over 6 is equal to 1/2. And that's the same as cosine of pi over 3, replacing this angle with the radian value. And if I've got cosine of pi over 6, that's going to equal square root of 3 over 2, which is the same thing as sine of pi over 3. So now what we can do is put those values on a unit circle, look at the x and y values. If you look at pi over 6, notice that pi over 6, the sine is the y value, the cosine is the x value. If you look at, instead, the 60 degrees or the pi over 3, the cosine, this 1/2 is the x value, the sine value is the y value there, and again it translates to the reference angle in each of these quadrants and what the values of the x and y are, just adding the negatives when you need to in the different quadrants. So what this allows us to do is we have a summary unit circle down here. This is our unit circle. And this unit circle, this unit circle gives us the values for these specific but very generally used angles by looking at the x's and y's. So if you look at this unit circle, it summarizes for us, if you want to find, for instance, if you want to find cosine of, let's say, 5 pi over 6, you go to 5 pi over 6 and you take the x value. So cosine of 5 pi over 6 allows us to look at this cosine value and get negative square root of 3 over 2. If I want to know what the sine is of 315 degrees, so I'm going to go to the degree measure. So this one summarizes as both the radians and the degrees. So sine of 315 degrees would be the y value on this one. So negative square root of 2 over 2. So this unit circle summarizes a lot of the values of the 45, the 30, and the 60 degree angles. Gives you those values by using the x and y values. The x is the cosine of the angle and the y is the sine of the angle.